Hi everyone, welcome to your lecture on theories of emotion and the experiencing and the expressing of emotions. Emotions seem to be things that we feel like we readily identify but can't always explain. It explains why there are thousands upon thousands, it seems, of new emojis popping up to express emotion. So emotion must be something that is important to our normal communication and the way that we interact. So what is an emotion? For this course, it's important that you recognize the three components of an emotion. The first thing that you look at is the cognitive component, the part that's going on inside the gears of the person's head. So this is their experience. This is what they think about it. This is how they interpret the event. And this is going to be unique to the individual. This is why to somebody, one thing can be terrifying, and to another, it can be exhilarating, and to maybe another, it can be incredibly sad. And it all depends on their understanding of the event. This can be then accompanied by a bodily arousal. What is going on in the internal workings and mechanisms of your body? What hormones are being released? How is that impacting your sympathetic or your parasympathetic systems? So again, your body is going to start to respond to these things. And then lastly, there's going to be an overt expression, the way that you show the emotional component, and that's the behavioral part. So when we're talking about emotions, we have a thought part, we have a physical part, and then we have a behavioral part. This leads to the question that was posed a long time ago. Does your heart pound because you're afraid? Or are you afraid because you feel your heart pounding? We're going to first start talking about the three major theories of emotion. That will be the James Lange theory, the Cannon-Bard theory, and then the Schachter-Singer two-factor theory. And they all differ on some very key points. The James Lange theory was proposed by William James, and then also a man named Carl Lange. They didn't collaborate on the theory. They actually established similar theories around the same time, and they were just combined into this one theory. This theory states that to have an emotion, you must first have some form of physiological arousal. So a stimulus causes a physical reaction. Somebody jumps up and your heart starts to pound. That physiological reaction produces an emotion. So my heart is pounding, that must mean I'm afraid. But this runs into some problems because we would also say my heart is pounding, so I must be excited. Or my heart is pounding, so I must be feeling love. And this is why this theory is often considered disproven. Now there are elements of it that do hold true in certain circumstances, and we'll talk about that in a bit. Paul Ekman in 1980 was able to show that James Lange wasn't entirely incorrect, that there were some elements of his theory that did hold true. He did this when he had subjects either consciously make a surprised, a sad, or some other associated face, and that they then felt or were able to show that they had some small amount of that emotion. This is something that you can replicate yourself, and it really just requires a pencil and some Sunday comic strips. So I did this once with a class and asked them to hold a pencil between their upper lip and their nose. By holding the pencil in place using your upper lip and your nose, it forces people to frown. The other option was to hold a pencil as far back to your kind of back teeth as possible, and this causes people to smile. Now, half of the class held the pencil in a way that caused them to frown, and the other half held the pencil in a way that would cause them to smile. And then I gave them comic strips, Peanuts or whatever comic strip was available that I could find on the internet. And they weren't terribly funny, but students had to rate how funny they thought the comics were. And it was interesting because the students who were forced to make the frowny face really didn't find them funny, and the students who were making the smiley face started to laugh out loud. So there is some credence given to the idea that what we do express facially may change what we feel emotionally. But the next theory that we're going to talk about is called the Cannon-Bard theory. And Cannon actually had some pretty strong criticisms of James Lange theory. First, he said, there are people who have spinal columns that are severed, and in doing so, they can't have all of the physical reactions that we would have to emotion, but they still have a full range of emotion. Our visceral organs don't respond to stress quickly enough for it to be based off of just physiological. the fact that we could cry because we're so happy or cry because we're so sad, they require the same physical emotions, but they're not the same emotion. And we can actually stimulate things like your heart or other visceral organs, and no emotion gets produced. There are two ways to kind of remember the James Lange theory and all of the subsequent theories. One is by memorizing a scenario, the other is memorizing a flowchart. And unfortunately for these, it does require some amount of memorization. So in this scenario, we have a young woman and a shadowy figure of a man in a parking lot at night. So the stimulus is the figure of the man at night. You see that in this case, I see a man by that parked car. That's the stimulus. That's the information coming in. There's a physiological arousal and behavior changes. So my heart starts pounding, I'm running away, and then after all of this, there's the experience of the emotion. And again, it's subjective, it's unique to the individual. So the easiest way of saying something about the James Lange theory is, my heart is pounding, therefore I must be afraid. My palms are sweating, therefore I must be nervous. My eyes are crying tears, therefore I must be sad. So again, you get the visual stimulus or the impact from the environment, you have the physiological change, and then you have the emotion. The second major theory that we're going to talk about is the Cannon-Bard theory. Now the Cannon-Bard theory, the most important word for this entire theory to make sense is the word simultaneous. The Cannon-Bard theory stated that physical reaction and that emotional reaction are actually two very separate and independent events. They just happen at the same time. So the thalamus sends out signals to the muscles and the emotional centers simultaneously. A visual stimulus comes in through the vision, and it must go to the limbic system and it must go to the body at the exact same time. But they're processed independently but simultaneously. So you would be shaking and feeling the emotion of fear at the same time. In this case, we're going to look at the exact same scenario, but we're going to apply a different theory. So Cannon-Bard, looking at this, goes with the exact same kind of stimulus, shadowy figure of a man in a parking lot at night. Instead of it being like James Lange, where your heart is pounding, you're running away, therefore you must be afraid. In this case, Cannon-Bard says that the physical, the running away, the pounding heart, is happening at the exact same time as your conscious experience of the emotion. So I am afraid and I'm trembling. I am afraid and I'm running away. They happen simultaneously. The last theory that we're going to talk about that's considered part of the big three is going to be the one that has to deal with cognition. So this one is going to be the Schachter-Singer two-factor theory. And the big thing that changes between Schachter-Singer two-factor theory and the previous two theories is that in this one, it's not simultaneous. It is not physical and then emotional. But there has to be an assessment of the environment. There has to be some form of cognitive appraisal. Think about and assess your environment. So, emotions are a mix of the physiological and the expressive behaviors, but that there must be thought. You must assess, you must think about the event, and that might explain why one person finds something incredibly surprising and funny, while another person may find the exact same event terrifying. How we think about events affects the experience of emotion. So there's the physiological arousal, and that can be undifferentiated state that has any number of labels. So again, your heart pounding can come from fear, but excitement, from joy, from elation, from dread. All of those things kind of hit different spectrums on emotion, but it still may have your heart pounding. The labels that we use to describe our emotions depend on the immediate environment and really what's in our heads, how we think about the event. Back to the exact same scenario, but now let's look at this with the Schachter-Singer two-factor theory. So, same stimulus, shadowy figure of a man in a parking lot at night. We go from that and we go, I see a man by that parked car. I'm trembling, my heart is pounding, my body's shaking. At this time, we also think about it. Is my heart shaking because I'm excited? Is my heart shaking because I'm afraid? And so the cognitive label, the thought process in the event, starts to determine the emotion. So, I don't know who he is, this could be very dangerous, I am afraid, and then we have the conscious experience of the emotion. So, my heart is trembling, this is an unsafe environment, I must then feel fear. This is another way of learning the big three. And for me, this is just how I remember it best. Put it into a flowchart and I can kind of figure out where the emotion pops in. So if you were driving down a road and you have a car coming at you, right down the median, right down the dead center, James Lang would say your heart would start to pound and then you would have the feeling of emotion. So heart pounding, then emotion. And as you notice in the flowchart, they're not side by side, it's one on top of the other. Cannon-Bard theory says that they happen simultaneously, therefore they're just right next to each other. And then Schachter-Singer two-factor theory, you see the two factors that then lead to the emotion of fear. So the pounding heart plus the thought process or the cognitive label, that ultimately leads to the emotional state. So hopefully you're feeling comfortable with the big three, because now we're going to get into more people who want to just mess it up and make it harder to learn. The first person we're going to talk about is a man named Robert Zajonc. And Zajonc believes that some of our emotional reactions actually don't involve any deliberate thinking or that cognition is always necessary for an emotion. In fact, what he thinks is that there are some neural pathways that bypass what he would call the higher cortical areas involved in thinking. So a stimulus comes in either through your vision or your hearing. The thalamus may route it directly to the amygdala, and he said that this is probably involved in those kind of behaviors that are really going to be helping us with just basic survival. And so it enables a quick, almost kind of a dirty emotional processing, that it doesn't go through all the proper channels, but that we just have a reaction to it. An example that Zajonc brings up is something like, we know how we feel about a situation before we think about the situation. So just imagine yourself raking leaves and you hear a rustle. You don't know if it's the wind or maybe a snake in the leaves. First you feel fear and then you actually take the steps to determine whether or not you should in fact notice that there is a danger present. People can develop an emotional preference for stimuli to which they have unknowingly been exposed. So Zajonc believes that sometimes emotion can precede cognition. But what we're going to find out later is that with this, while it may precede cognition in the moment, chances are you can't feel fear towards something that you've never thought about. And that'll lead us into our next researcher. This is a visual of what Zajonc was trying to explain. Here's a snake, and if you were to see this, chances are that the visual image or the stimulus of the snake would go directly to the thalamus, and the thalamus would sit there and go, let's send this right to the amygdala, have an emotion of fear before it even gets to the visual cortex for us to recognize what it is that we're afraid of. This would make sense if we're talking about pure survival, if we're talking about something that's very evolutionary based. Richard Lazarus is going to be somebody who disagrees a little bit with Zajonc. And again, he's going to bring in this idea of cognitive appraisal. So I left you with this idea of how could you know you're afraid of something if you've never thought about it? And so Lazarus agrees with Zajonc that, yeah, you can react without truly thinking, but you wouldn't know what emotion to apply unless you had thought about it before. Agrees that the brain reacts to a vast amount of information without real conscious awareness, and that some emotional responses don't require conscious thinking. But that means for him that there must be something that happens at an unconscious level, that our emotions must be triggered by something that's kind of going on without us being fully aware of it. He said, how else would we know what we're reacting to unless we had thought about it at some point? If we're looking at the two routes to emotion, we're going to compare Zajonc versus Lazarus and his cognitive appraisal and the Schachter-Singer two-factor theory. If we're looking at Schachter-Singer versus Lazarus, the big difference is that with Lazarus, the appraisal, the cognition, may not be at a conscious level. Where Schachter-Singer two-factor, there is a conscious appraisal of the emotion. So, if an event occurs and it goes directly to emotional response, you're looking at Zajonc. However, if an event occurs and you think about it, whether at a conscious or an unconscious level, you are talking about Lazarus and Schachter-Singer. If it happens at the unconscious level, then it's Lazarus, and then you have your emotional response. And if it's at the conscious level, you experience it, you think about it, and then you have an emotional response. That would be Schachter-Singer. As we move past the theories of emotion, we also start looking at the different dimensions of emotion that we may have. So, research done by Russell Watson and Tellegen and others describe emotions as a variation of dimensions, low and high arousal, and then pleasant versus unpleasant balance. It's important to look at the following slide and to memorize what low, high, unpleasant, and pleasant really mean. Looking at two dimensions of emotion, you have low arousal and high arousal, literally meaning kind of emotional expenditure. And then you have positive and negative. Positive valence, consider those good or happy emotions, where negative valence, those are, again, what they sound like, probably negative or bad emotions. So, low arousal, positive emotion, that's just being chill. Low arousal, negative emotion, that's sad. High arousal, positive, you might have something like exuberance and joy, and then high arousal but negative, that might be anger or fear, something's a bit more emotionally expressed. Going back to this concept that there is a cognitive component to emotions. One, we have over 550 words in the English language that just express feelings. We've constructed emojis to help further communicate emotion when it comes to texting and emails because we were having a problem making sure that people understand the emotional intent often of what we were writing. Emotions can be really subjective. So when we look at it, the way that people think about something often determines the emotion they experience. Just remember a time that you read a text or an email or something and your understanding of what the person wrote didn't fall in line with what they intended. And because they didn't properly express it, or maybe because you were in a certain emotional state when you read it, it changed the meaning entirely. Any discussion of emotions must bring in a discussion of the autonomic nervous system. You should recognize the amygdala, the part of the brain in the limbic system that is used to regulate emotion. That's going to be utilized when we talk about the autonomic nervous system, often with fight or flight, the production of fear. Your autonomic nervous system is a subdivision of your peripheral nervous system. Autonomic and somatic are those two subdivisions. Your autonomic then further subdivides into your sympathetic and your parasympathetic. Your sympathetic will activate for things like fight or flight, while your parasympathetic, that is meant to kind of calm you back down after those incidents. Here we're looking at a division of the brain, and you see the amygdala. And again, this is going to be the structure that Zajonc thought about when he talked about that kind of quick and dirty processing of emotional stimuli. That sometimes information may get routed directly to the amygdala, especially if it is going to be something heavily related to fight or flight. This section will come right back to talking about fight or flight, so you need to remember the difference between sympathetic arousal and your parasympathetic calming kind of divisions. So it's the difference between feeling like you're being attacked by a tiger or just walking around in a state of calm. You need to remember that if it is going to be something that will operate in fight or flight, either shutting it down or amping it up has to be done with the intent to keep you alive. So things like your perspiration in your skin. Well, your skin's going to perspire to keep you cool. Your respiration is going to increase. Your heart rate is going to accelerate. All of those things help oxygen and nutrients get to your muscles. Your digestion is going to stop because no one needs to digest food if you're about to die. You're going to secrete all sorts of stress hormones. And again, when you get to your parasympathetic, all of those things will either decrease or stop. One way to measure emotion in laboratory studies is by measuring something called the galvanic skin response. When we become stressed or we have autonomic arousal, it increases the sweat that we actually have in our skin. So this increase in electrical conductivity of the skin occurs when sweat glands increase their activity. We can measure this as an indication of whatever emotion it is that we think someone is experiencing in a laboratory setting. What you see before you looks a lot like the Yerkes-Dodson curve, but what you should also see is that there's some positive and negative skew going on, and neither of these curves is a perfect bell curve. We are talking about performance and arousal again, but in this case we're talking about the difficulty or the ease of which a task happens. So Yerkes-Dodson said that our best performance is when we have moderate arousal, but it didn't really look specifically at the ease or the difficulty of a task. When a task becomes incredibly difficult, we get more of a positive skew. difficult tasks still want somewhat moderate arousal, but it has to be closer to the low end of arousal. If it's if it's an easy task, the reverse is true. We have more of a negative skew, but we need higher arousal to actually make the person perform their best. Easiest way to explain this, I always go with heart surgeons versus Minute to Win It. If you are doing open heart surgery, chances are, because that is such a difficult task, you probably want lower arousal. In other words, you don't want to be stressed out. You want a very calm environment. You want things to be quiet. That way you can perform after your actual best. If, however, we're looking at whether or not you can pull tissues out of a box, for your performance to be the best, you may actually want the constraints of do it within a minute. So the higher the arousal with an easier task, the greater the performance. There are multiple physiological states that accompany different emotions. When we look at fear and rage, kind of two ends of a negative spectrum, finger temperatures and hormone secretions actually differ. If we look at something like negative fear versus positive excitement, they have the exact same heart rate. So similar heart rate, your heart's going to be pounding, but there's going to be different versions of muscle tension that's recorded above the eye. So if you think of positive excitement, our eyes usually get wide. If we think of things like negative fear, our eyebrows kind of tense in. When we look at disgust, the right hemisphere of the brain becomes active. When we think about positive emotions, the left hemisphere of the brain becomes active. Everyone is able to read nonverbal communication. However, some people do it a little bit better or with more ease than others. When we read nonverbal communication, we're usually reading it from something like the eyes and the mouth. We read fear and anger mostly from the eyes, happiness from the mouth. When we look at people who tend to be a little bit better at reading people, introverts who tend to often be natural people watchers are better at reading emotions, and extroverts tend to be better at expressing them, so they're easier to read. Females are usually better at reading people's emotional cues, and there might be an evolutionary underpinning to this, simply the idea that for women they would have had to respond to nonverbal cues from infants, and so evolutionarily we might just be a little bit better at it. And that doesn't mean men can't do it, it just means the ease at which it comes to some. Women also react more visibly to emotions, which will explain the following slide. This slide always seems to explain my television viewing with my husband. Whether it's sad, happy, or scary, I'm more likely to actually have an emotional response to the movie. I'm more likely to laugh out loud, I'm more likely to tear up, I'm more likely to freak out and get scared. We could be watching something that we both find absolutely hilarious. I'll laugh out loud, and I'll look over and he might be smiling. And my first question to him will always be, do you not find this funny? Or are you not scared? And he'll respond that he's feeling the exact same emotion. He's just not expressing it as verbosely as I am. Women and men differ at the emotions that they express best. Women are better at conveying happiness. Men convey anger better. And again, it's not that men don't have a full range of emotions, and it's not that women don't get angry. It's just that culturally we express things differently, and men do have greater amygdalas, and anger would have served them as a survival mechanism much better a long time ago. We've already kind of touched on that email communications and even text communications lack nonverbal cues and therefore can often be misinterpreted. And something that we would get into more detail in something like sociology is that gestures actually vary with culture. So giving someone the peace sign here in the US, it really doesn't matter which way you show the peace sign. Give that to someone in England, you better hope that you have it with your kind of fingers or your thumb to the outside instead of the smooth back of your hand showing, because one means peace, the other one you're flipping them off. Culture has a lot to do with emotional expression. When we look at it, again, I told you that gestures vary with emotion, but let's look at the research that was done by Ekman, Friesen, and later by Carol Izard. They looked at the fact that there are certain facial expressions that are universal to all people throughout the world. Culture and language share many similarities in the ways that they categorize emotion. And in the next slide, we'll look at the basic emotions that they feel all people have. The research that was done by Carol Izard showed that even blind athletes had these emotions. So people who were not sighted, who could not possibly have seen or have reference points for emotions, still did things like show anger by furrowing their brows, or show joy by smiling and having the upward kind of corners of their mouth turn up. Display rules, that's where culture really kind of gets into what emotions we have. They're often learned during childhood. You fall down and you start crying, and someone tells you that you need to get over it, or you need to toughen up, or it's not that big of a deal for you to make such a display. We learn to mask emotion, we learn to exaggerate it sometimes. You know that if someone tells you joyous news, even if you don't care, there's a certain expectation that you're supposed to celebrate for them. Culture will tell us what emotions we're allowed to display. So if you were to go to a funeral, even if you weren't truly sad, maybe you didn't even know the person, your culture, our culture, dictates that you should put on a kind of a solemn expression, and you should at least look as if you are sad or bothered by it. Expression of emotions is often dependent on the situation and then who is present at that situation. As discussed in the previous slide, there are culturally universal expressions of emotion, and it's known as the facial feedback theory. If you can, click on the link, and that should take you to Carol Izard's study. Here, if we look at the 6 different emotions expressed, for A, in all cultures, this would be joy or happiness. B, the idea of the eyebrows arched and the wide eyes, that's surprise. For C, you have something like fear. For D, it's sadness. For E, that's anger. And for F, you're looking at something like disgust. If you're ever uncertain, just make the facial or mimic the facial expression, and very quickly it comes to mind what emotion should be expressed. Research into facial expressions is important. It starts back with Darwin, and he looked at facial expressions as having an adaptive role, that they communicated emotional states to others. The universal occurrence of facial expressions and emotions, or that facial feedback, shows that these emotions exist throughout all societies everywhere. And looking at blind infants show that we all have these innate facial expressions without ever having been taught. Facial expressions can also be used to amplify but also regulate emotions, to hold it in or to express it. Many of us believe that we can detect something like a false emotion. And unless trained to recognize subtle signals, most people have difficulty detecting feigned expressions. However, if you take something that we have kind of a general understanding of how it should be expressed, when things no longer fit into kind of the authentic time frame, we do notice. So smiling for 4 to 5 seconds. 4 to 5 seconds doesn't sound long, but normally we don't hold smiles that long, especially if it's not something that is creating like a true sensation of joy. So someone who sits there and smiles at you for 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, if the situation doesn't dictate that that long of a smile should occur, we often find that smile to be false. Ackman and O'Sullivan looked at whether or not there are certain groups of people who are better at detecting things like lying. And when they looked at 6 different groups, the only group that did a little bit better than chance was the U.S. Secret Service agents. But they only did a little bit better at 64%, which indicates for us that really even trained professionals can't always detect emotion. That brings us into something like a lie detector. Lie detectors or polygraphs actually measure your autonomic nervous system reactivity. And so they look very different than often what you will see on television. But it's going to look at your heart rate, your perspiration, your breathing. But the problem with a lie detector is that it can't distinguish between the similar physiological states that accompany multiple emotions. So anxiety, fear, and irritation and guilt, they all have very similar physiological reactions. And so you might just be irritated, or you might be anxious, but you might not be guilty. The test often labels the innocent as guilty more often than it does the guilty innocent. It has an 85 to 90% accuracy rate, but to introduce something like that into a court of law, there's too much error in that 10 to 15%. Viewing a polygraph, or at least the data that's generated from it, here we're looking at innocent people versus guilty people. Now, while the judged innocent by the polygraph but found guilty is not necessarily great, what we're actually more concerned with is the 37% of people that were innocent but that were judged guilty. That explains, or at least one area of why polygraphs, while they give us good information, aren't utilized as factual evidence in courts of law. Facial feedback theory said that there were basic facial expressions that are universal to all of us. Matsumoto in '94 and then Carol Izzard back in 1977 said that there were different basic or recognized facial expressions of emotion. Izzard said there were 10. Matsumoto more recently said that there were 7. It's really important that you recognize the 7. Don't worry so much about the 10. So anger, disgust, fear, happiness, sadness, surprise, those were the 6 that we saw in the previous slide. The only one that you need to add to those 6 is the idea of contempt. Any discussion of emotion is going to take some time out to talk specifically about fear. So fear is going to fall under adaptive because it plays such a huge part into fight or flight, preparing our bodies to flee a danger. It can also be something that can be easily learned. Classical conditioning, if we're looking at that, might be that you were bit by a dog and now you have a fear response to all dogs. Observational learning, maybe your parents were the ones that were bit by a dog and they show fear, and just by being around them and watching them fear dogs, you fear dogs. We also want to look at the biology of things like fear. So when we're looking at something like the biology, there is the biological preparedness or the preparedness theory, and that literally goes back to that evolutionary idea that maybe, just maybe, our ancestors who were afraid of things like heights or spiders, they were the ones that survived, and therefore they passed their genetics on to us, and we are more likely to be afraid of certain things. There is the activation in the amygdala. Phobias come from whether they were classically conditioned, maybe even observationally learned, and some people are just going to be more emotionally reactive than others. The biology of fear is very simple. Information comes in as a stimulus, the thalamus detects it and sends that information to the amygdala and then also to other cortical areas for processing. If the amygdala is stimulated for fear, it's also going to activate the sympathetic division of the nervous system, and it's going to activate your hormonal system or the endocrine system. It's going to start pumping out things like adrenaline, getting you ready for fight or flight. Anger is another emotion that we need to talk about in its own kind of individual context. Now, just like fear, it can be classically and observationally learned. But anger is also going to be influenced by things like frustration, the inability to get to a goal, crowding or being in close proximity with other people, extreme temperatures, either too hot or too cold, having aches or pains, and then also bad odors. So if you've ever been in a long car ride with a bunch of people and you're crowded into the car, eventually you're probably going to start getting annoyed. And let's say in that crowded car you are stuck sitting in a position that starts to hurt. Well, that should increase your anger also. And while you're in that car, let's say that they don't want to run the air conditioning because they want to save on gas. And so even with the windows down, everyone's sweating and everyone's uncomfortable. Your anger increases there. And finally, the straw that breaks the camel's back, well, that one, someone decides to fart. And at that point, you may find that you react in a very angry manner, and people may tell you to calm down, that it's not that big of a deal, but it's this they've ticked off pretty much every single box to the things that should just make you angry. And then there are cultural differences when we look at anger. People in individualistic societies often feel more free to express anger, where collectivist societies, anger might be seen as more destructive and, again, less likely to be expressed. The biology for anger is important. You should recognize the amygdala is going to be highly active in anger, since that's your emotional center. Hippocampus plays a big role because we remember things, and that becomes part of that cognitive component. You might remember something that triggers anger. You might remember a situation that previously made you upset. Testosterone is going to be the hormone that is most associated with anger, so people with higher levels of testosterone are more likely to have anger. And again, when we look at twin studies, you have this idea of reaction or reactivity, and we see that between identical twins, the expression of anger tends to be rather similar. In dealing with anger, it used to be the catharsis hypothesis that researchers would go to and therapists would go to try to get people to kind of express their emotion. They thought that if someone were able to express their anger or aggression, they would kind of exhaust it from their body. And so just imagine you're really upset, you're really angry, and you go upstairs and you hit a pillow. The advantage is that it can be temporarily calming. It can get it out of your system a little bit, but it can also leave you feeling anxious or guilty, but it might also end up reinforcing aggression and anger, so it may lead to more anger. More current evidence supports that this catharsis idea actually doesn't decrease, it actually increases aggression. With the emotion of happiness, there is actually one or two things that you really do need to know. The first one is something called the feel good, do good phenomenon. And while most of us kind of read this and it makes sense in our heads, this one is definitely something that will be on the test that you need to be able to replicate and talk about. So, if you feel good, if you actually are in a happy mood, it increases the likelihood that you will in fact do good. And so by making other people feel good, it increases the likelihood that they'll do good. And then when they do good, they may make someone feel good and then they'll do good. And so if you've ever been in one of those kind of pay it forward lines where you get into Starbucks or something and someone's already paid for your drink, because that may put you in a happy or a good mood, it's more likely at that point that you are then going to do something nice for others. This might also be the someone let you out, so you let someone else out into traffic kind of mentality. There is subjective well-being, so self-perceived happiness or satisfaction with life. People who see the upside, people who are happy with where they are or content, are more likely to experience happiness. And it's used along with measures of objective well-being. Objective well-being is this idea that you compare yourself to people in similar circumstances. You don't compare yourself to the insanely rich or the insanely poor. So physical and economic indicators to evaluate people's quality of life are often used to look at their kind of well-being. Relationships between wealth and happiness don't exist. There is a certain point with wealth where the greater the wealth doesn't increase the greater the happiness. But we will say on like the lower end, wealth doesn't make you happy, but it can alleviate some of the stressors that would make you unhappy. So here again, does money buy happiness? And we're looking at the year average income and where people say they're happy. If you're really impoverished, to hear something like money doesn't buy happiness, no, it might not. But being able to pay your heating bill and to provide food for your family, that does provide you with some form of happiness, or at least life contentment. At this point, we're looking at that there is a point of personal income where people sit there and go, all right, happiness stays relatively right about here. And usually when we're talking about this, we're talking about, middle income type lifestyle. We're nearing the end and there's still a couple of theories that you guys need to know. Adaptation level principle. So we adapt to the stimulus that gives us an emotion. Now with this, that doesn't make a whole lot of sense, but this is why I always say don't go big with promposals or homecoming, things like that. Here's why. There's a certain level of stimulus that makes us happy. And for us to feel happier, we need an increase. If you go big on the little things, you have to go super big on the big things to make an impact on that person emotionally. So, if your promposal has you skydiving and doing something huge, your wedding proposal has to be bigger. Otherwise, that person is going to go, I was so happy with this one event. Here, this other social event that's supposed to be so much bigger falls short. So we adapt to levels of stimulus that make us feel something, and we need increased stimulus to make us feel happier, which is why if you are somebody who brings flowers home for somebody every week, and one week you forget, well, they'll fall below that adaptation level and they'll go, oh, well, now I'm unhappy. But come back the next week, they're not going to feel happy. It becomes normal. And you're going to have to do something bigger to make them happy. The relative deprivation principle, the sense that we are worse off than others with whom we compare ourselves. Well, this is going to be when we compare, look at how happy they are, look at how they smile, look at how wonderful their lives are. That we compare ourselves with others and that maybe we're the ones that are worse off. That's really not, in most cases, true. So when we look at what predicts happiness in most people, people who like themselves tend to be happier. People who are optimistic, that the world isn't all doom and gloom. People that are a bit more outgoing or agreeable tend to be happier. They're not constantly in conflict. People with close friendships. Now, close friendships doesn't mean lots of friends. It means people who truly know you. People who have things that engage their skills, whether it's work or a hobby, but something that makes them feel active and purposeful. People with religious faith. Now, for some of you, this might be something where you're like, well, I don't agree, but people who believe in a higher power or that can sit there when there are things that are tragic or difficult, can believe in something, that sometimes makes them happier. And then sleep and exercise, that increases endorphins, it gives you a healthier body. They're very, very important for our overall happiness. Last slide for the entire thing. When we look at happiness, people with high self-esteem, they tend to be happier. Optimistic, outgoing, tend to be everything that we talked about before tend to be happier. However, not related to happiness, age. So you can meet someone who is 75 and they are the happiest they've ever been. And you meet someone who is 15 and super happy. But the reverse is true. If they feel like they're not engaged, if that their work or their skills are not being utilized, doesn't matter their age, they're probably still going to be a little unhappy. Your gender, doesn't matter if you're male or female, that doesn't seem to affect happiness. However, women do often experience depression a bit more. Education levels, having or not having children, being attractive or not attractive, these things don't really seem to impact happiness. So with this last slide, I hope you guys are prepared with everything in here. Go back, look over the three major theories, make sure that you're good with facial feedback, make sure you're good with adaptation level principles, all of the things that were talked about.